Hello everyone, welcome to my YouTube channel. In this video we would be solving questions based on trigonometry which has appeared in O-level exam. Course code is 4024. And before solving the questions which has appeared in O-level exams, we should be knowing a few important things first. To begin with, what you should be knowing about is the trigonometric ratios. You know that in case of any right angle triangle, we always have three important sides, and those important sides are hypotenuse, then we have a base and a perpendicular. With respect to all these three sides, the trigonometric ratios in a right angle triangle are represented as, suppose if this is taken as angle theta. So with respect to this angle theta, the first ratio sine theta can be written as sine theta is equals to perpendicular upon hypotenuse. Then we have second ratio, which is cos theta. Cos theta would be equals to base upon hypotenuse. And last we have tan theta, which is equals to perpendicular upon base. Right? So you should be knowing all these trigonometric ratios in a right angle triangle. Apart from these ratios, we have Pythagoras theorem. Pythagoras theorem is again the relation between three sides in a right angle triangle, which is written as hypotenuse square is equals to base square plus perpendicular square. Next, we have the ratio sine rule and cosine rule, which are applied in case of a triangle which is not a right angle triangle, a non-right angle triangle. Suppose if you have this triangle as triangle ABC. Always remember, in case of a triangle ABC, the side opposite to angle A would be represented by small a, side opposite to angle B would be represented by small b, and the side opposite to angle C would be represented by small c. So with all these three angles and three sides, the sine ratio is defined as sine A upon A equals to sine B upon B equals to sine C upon C. This relation is used to find any of the unknown angles or any of the unknown sides depending upon the conditions. Whenever you are having one complete pair, by one complete pair means an angle and a side, that completes a pair. So whenever you are having one complete pair and one side or angle, you would always be using a sine rule. For cosine rule, it's stated as a square is equals to b square plus c square minus 2bc cos a. In simple words, whatever side has to appear here, its angle should be given. For A, we have this angle A. So always remember, the side appearing here should be with respect to angle appearing on the other side for cos. And then for a triangle, which is a non-right angle triangle, the area can be obtained as area is equals to half AB sine C. Last important concept, it's about bearing. For bearing, you can also refer my other video, which is specifically made on the concept of bearing. You can understand the concept of bearing in that video. And it's used for the calculation of angle. And for angle, the reference line is always the north pole, and the direction of rotation is always clockwise. Moving onwards, the first important angle to be known, it's the angle of elevation. For angle of elevation, it's always the angle which is measured from the bottom to the top. From the bottom to the top means if we have anything standing vertically, let it be represented by AB, be it a cliff, a mountain, a wall, a tree, anything which stands vertically above the level ground. And we have another point on the level ground, let it be point C. So whenever you are asked to find angle of elevation of B from C, so in that case, it would be this angle made at the bottom. So angle of elevation of B from C. Of B from C, C has to be on the level ground. So this would be the angle of elevation. Then we have angle of depression. Angle of depression works opposite to angle of elevation. In case of angle of depression, there would again be something standing vertically, let it be AB, and there would be a point on the level ground. Now for angle of depression, angle of elevation, it's angle formed from the bottom to the top with respect to the horizontal line. And angle of depression would be the angle formed from the top to the bottom. Top to the bottom, again, it has to be with respect to a horizontal line. So if it is said as find the angle of depression of C from B, so in that case on B you would be having the reference line. So angle of depression of B from C would be this angle. What students make mistake in finding the angle of depression is they are taking this angle as the angle of depression, whereas you would be finding this angle, but the complement of this angle would give you the angle of depression, because angle of depression has to be made with respect to the horizontal line, and this horizontal line has to be made on the point which is vertically above. The third important concept to be known about trigonometry is the shortest distance. For shortest distance, it would always be the perpendicular distance. Now, for example, if you have this triangle ABC, and in this triangle ABC, what you are given as is, you are given with this angle, let it be 30 degrees, and you are given with this side BC as, let's suppose, 8 centimeter. And you are asked to find the shortest distance from C to AB. Now remember, the shortest distance has to be the distance from a point to a line. And from a point to a line, it would always be the perpendicular distance. And to find the perpendicular distance, you should be having a perpendicular drawn from the point to the line. So this is the perpendicular drawn. So basically, if this point is X, so you are actually need to find the side CX. Now, if I may draw the triangle separately, you would be having a figure somewhat of this nature, in which you would be having this angle as 30 degrees, this side as 8 centimeter, this point being C and this point being X. So you are actually need to find CX here. Now to calculate CX, simply we can apply any of these right angle triangles ratios. With respect to the angle given 30, it's the opposite or the perpendicular side which needs to be found. So we can apply the sine ratio here. So sine ratio can be applied as sine 30 is equals to perpendicular upon base means Cx upon perpendicular upon hypotenuse means Cx upon 8, and Cx would be equals to the product of 8 and sine 30. This can be calculated with the help of a calculator. So 8 times sine 30 equals to 4 centimeter. So this would be the shortest distance or the perpendicular distance between a point and a line. Now we can move on to solve the question from the past paper. The question I have chosen for this from the past paper is having the reference June 2012 paper 2 question number 8, and in this question the conditions given as we have a kite being represented by point A, which is vertically above point D, and we have another side labeled as BC. Now in this figure we are given with three different sides: side AB as 20, side AC as 21.3, and side BC as 2 units. Now in the first part we need to find the angle ABC, means this angle. Now if I may draw the triangle separately, you would be having this kind of figure. Having the points as A, B, and C, and the sides are 2, 20, and 21.3. So always remember, whenever you are asked to find an angle with the three sides given, you would always be applying the cosine rule. It's a very important thing. Whenever you are having three sides in a triangle and you're asked to find the angle, you would always be using a cosine rule. Now, cosine rule to find this angle, the opposite side to this angle is 21.3. So with respect to 21.3, the formula can be applied as 21.3 square is equals to 20 square plus 2 square minus 2 times 20 times 2 times cos of B. And we can solve this with the help of calculator, which would give us the value as 21.3 the square minus 20 the square minus 2 the square, which is equals to 51. Sorry, I have made a mistake here. 21.3 the square minus 20 square minus 2 the square. This gives us a value as 49.69 equals to minus 2 into 20 is 40 into 2 is 80 cos of B, and B would be equals to cos inverse of 49.69 minus upon 80, which would give us the value as shift cos inverse bracket minus 49.69 divided by 80, which is equal to 128.39. And for one decimal place, the angle would be ABC equals to 128.4 degrees. In the next part, we are asked to find the side AD. Now AD, we can see in the figure, AD is this complete side, and to find this complete side we have to divide the figure. Now if I may draw an imaginary line here, we know that it's opposite to this segment, it's this, which would be of 2 units, and the remaining part can be labeled as X. Another important thing to be divided here is this complete angle was 128.4, as we have found. Only this part would be the difference of 128.4 and 90 degree. So this would eventually be of 38.4 degrees. So we can draw the triangle separately for our convenience, and the triangle can be drawn as like this, in which we have this angle as 38.4. This side is X, what we need to find, and this side is 20. So with respect to this angle, we have to find a perpendicular, and a hypotenuse is given, so we would be using the sines ratio. So sine 38.4 equals to X upon 20, and X would be equals to 20 times sine 38.4, and this can be calculated as 20 times sine 38.4, which is equals to 12.42, and the required side AD would be equals to the sum of 12.42 and 2, which would be 12.42 and 2, resulting in 14.42, and the unit in this case is meter. So AD equals to 14.42 meters. This completes the second part. Now in the next part, here we can see we have another point on the ground which is E, and it's in such a manner that the triangle obtained on the level ground is DEC, and in this triangle we are given the side 8.6 DE, the angle DEC is 118, and the angle EDC is 33 degrees, and we are asked to find the DCE angle. Now it's simple. This can be found by applying the concept of sum of triangle, and the sum of triangle, this would result in DCE equals to 180 minus the sum of 118 and 33 degrees. So this would give us the value as 180 minus 118 minus 33, which is equals to 29. So angle DCE would be equals to 29 degrees. Next, we need to find the side CE. Now to find side CE, I'm again drawing the triangle separately. CED, angles inside the triangle are 33 degrees. This is 118 degrees. And this we have calculated as 29 degrees. And opposite to this angle, we have the side as 8.6. And we are asked to find CE. Now here, to find CE, we do have an angle opposite to side CE, which is 33 degrees. And we have one complete pair. So here we can easily use the sine rule to find the unknown side. The sine rule can be applied as CE side upon its opposite angle, sine of 33, equals to the another given pair, which is 8.6 upon sine of 29. So CE would simply be equals to 8.6 times sine 33 upon sine 29, and this can be calculated with the help of a calculator, giving the value as 8.6 times sine 33 divided by sine 29, and this gives us the value as 9.66, can be rounded off to 9.67 meter. In the last part, we are asked to find the angle of elevation of B from E. Now to calculate angle of elevation of B from E, I am drawing the triangle. We need to find this angle, this small angle. Angle of elevation of B from E. So we have this line drawn on point E on the level ground. If I may draw the triangle separately, the triangle formed would be of this nature, having the sides as BC being the perpendicular and E on the level ground. CE we have calculated as 9.67 and BC is given as 2 units, and we need to find this angle. Let it be alpha. So with respect to angle alpha, we have a perpendicular and a base. So connecting perpendicular and base, we have the tens ratio, and tens ratio can be applied as tan alpha is equals to perpendicular, which is 2 upon base, which is 9.67, and alpha would be equals to tan inverse of 2 upon 9.67, giving the value of alpha as tan inverse of 2 upon 9.67, which is equals to 11.68 degrees. Right? So this completes our question. Thanks for watching.